Hello student, let us start now the chapter 2, inverse trigonometric function. But before going to the main course of class 12, I'll just give you a brief revision of trigonometry, because in inverse trigonometric function, everything we have got in earlier classes about trigonometry we have to use. So listen carefully, okay? So in the case of trigonometry, you see, you have to consider a right angle triangle. So I have considered ABC is a right angle triangle, right angled at B. Okay, so here you know, in the case of a right angle triangle, the side opposite to the right angle B is your hypotenuse. Is not it? This is your right angle. So opposite to B, the side is AC. So AC will be your hypotenuse. Now, let us consider one of the angles. These are two acute angles because it is 90. So, other two angles will be acute, right? So, let us consider one of the angle as, say, theta. Here I am taking the angle C as theta. So, if theta is the known angle, and we suppose that this theta is known to you, okay? Also, if theta is a known angle, so the side near to that theta will be your base. Base means what? The near or adjacent side to the known angle. And the side which is opposite or distant from the known angle is considered as a perpendicular. So in this case, AB will be your perpendicular and BC is your base. Hope you remember. You have got all these things in class 10. Now you see, I'm just giving the definitions of what is sine, cos, tan, all this trigonometric ratio. These are nothing but the ratios of different sides of the triangle. So in case of, let us denote hypotenuse by h, perpendicular by small p and base by small b. Then you see, what is your sine theta? The formula of sine theta is perpendicular by hypotenuse. Okay, so what is perpendicular? That means this is AB and hypotenuse is AC. So this is your sine theta. After sine theta, next we have to know what is cos theta. Hope you remember all these things, but listen carefully so that you can easily remind all these things. Okay. So cos theta is equal to what? Base by hypotenuse. What is your base? Near side. Base means near side. So BC. And hypotenuse is the side opposite to right angle. That is your AC. Then I hope you remember what is tan theta. Tan theta is what? P by B. That is perpendicular by base. Perpendicular is your AB and the base is BC. Similarly, cos sec is equal to what? Hypotenuse by perpendicular. Okay. So, hypotenuse by perpendicular can be written as 1 by perpendicular by hypotenuse, just the reciprocal. I just bring this h to the denominator or divide both the numerator and denominator by h. We'll get it 1 by perpendicular by hypotenuse. And perpendicular by hypotenuse, this is known to you. What is that? This is sine. So, this is 1 by sine theta. As we know, cosec theta is equal to 1 by sine theta. Then if cosec theta is equal to 1 by sine theta, then obviously sine theta will be equal to the reciprocal of cosec. That means 1 by cosec theta. Same here in the case of sec. Sec theta is equal to hypotenuse by base, which is the reciprocal of what? Cos. So sec theta is equal to 1 by cos theta. Or in other words, you can say cos theta is the reciprocal of cos theta is 1 by sec theta. Now go to cot. Cot is base by perpendicular, which is the reciprocal of what? Tan. So cot theta can be written as 1 by tan theta, or tan theta can be written as 1 by cot theta. Hope you remember these things. Now let us go to the again some different relations. Now sine is equal, tan theta is equal to, these are the preliminary definitions we have got. All these are preliminary definitions. Now you see that tan theta is perpendicular by hypotenuse, that is known to you. So perpendicular by base, that is known to you. Now perpendicular by base, you can write down it as divide both the numerator and denominator by h. It becomes P by h by B by h. What is P by h? P by h is sine theta and B by h is equal to what? Cos theta. Same. So tan theta can be written as sine theta by cos theta. And also we know cot theta is equal to what? This is a relation. It's a very important relation. All these relations, it's a very preliminary and important thing. Okay. So try to remember all these relations. Now go for cot theta. Cot theta, you know, is the reciprocal of tan theta. And if tan theta is equal to what? 1 by sin theta by cos. Its reciprocal will be equal to what? Cos theta by sin theta. So these are the simple preliminary things we have got in class 10. Okay, try to remember it. Now you see the concept of sine is, here you see I am giving a diagram just to remember what are the quadrants and what are the different signs in the different quadrants. So you see I am drawing this x-axis and y-axis, or two cross lines, intersecting lines perpendicularly. They divide the whole plane into 4 parts. 1, 2, 3, 4. Each part is called a quadrant. When you rotate in anti-clockwise direction, this is your first quadrant, then anti-clockwise, second quadrant, that is third, and then fourth. Okay. So in the case of trigonometry, you know, all trigonometric ratios in the first quadrant are positive. Here all means all trigonometric ratios, if it is present in the first quadrant, they will be positive. In the second quadrant, sine is positive. Sine ratio is positive. Rest are negative. But if sine is positive, its reciprocal, that is what? Cosec, that is also positive. In the third quadrant, you see tan is positive. So since tan is positive, its reciprocal cot is also positive. And in the fourth quadrant, cos is positive. So what is the reciprocal of cos? That is sec. So cos and sec are positive in the fourth quadrant and rest are negative. This rule is considered as ASTC rule. Okay, all sine, tan, cos. These are the very preliminary concept we have got in class 10 or 11. Okay, now you see, let me go to the next one. Okay, here I want to tell you what are the different angles in the different quadrants we will have. So if I take theta as an acute angle, let us consider theta as an acute angle. Hope remember what is acute angle? Less than 90 degree. Yes, it is less than 90 degree. So if theta is an acute angle, this is your initial line. This is OX is your initial line. So you have to start with this. Measure the angle from this line, OX. I forget to give x-axis and y-axis here. So here this is your OX. So if theta is an acute angle, theta will lies in the first quadrant. And also, you know, in a quadrant, the value is equal to what? These are perpendicular. So value is equal to 90. If from this to this, if you go, this is your 90 degree. So if I have an angle 90 degree minus theta, then obviously it will be lies in the first quadrant. For example, suppose you take theta as 30 degree. Then 90 minus 30 will be equal to 60. And 60 will be present here. Suppose you take theta is equal to say 1 degree. 90 degree minus 1 degree, 89 degree, it is also present in the first quadrant. Again, if I take theta is equal to say 80 degree, 90 minus 80 is equal to what? 10. This is also present in first quadrant. So you understand that any angle of the form 90 degree minus theta will be in the first quadrant. Always see, if it is not mentioned, theta is generally considered as an acute angle. একো নকলে আমাৰ থিটাটো সদায় acute angle বুলি ভাবা হয়, less than 90, 90 কে সৰু. Now you see, you started with this. Suppose the rotating line present in this quadrant, here, second quadrant. Then second quadrant is the combination of this line, OY and OX dash. This and this line. Up to this, when it is covered, it 90 degree covered. Then 90 degree, you just come here and suppose reach this position. Some acute angle we have traveled. That means 90 degree plus theta we got. So 90 degree plus theta, this is in the second quadrant. Now suppose the revolving ray here starting from this and it comes to this position. It travel 180 degree up to this. This is 180 degree straight angle. So when it come back, theta angle minus theta means it come back, because you know anti-clockwise direction is positive. This is your anti-clockwise direction. Clock rotate in this way, so anti-clockwise direction is positive. So suppose you start from here and reach this position, then you travel 180 degree. After that, if you go back a theta angle, it will be in the second quadrant. So any angle which is in the second quadrant may be represented by 180 degree minus theta. That means the form of an angle in the second quadrant is either 90 degree plus theta or 180 degree minus theta. Remember, this is a very important concept. Now, let us go to the third quadrant. Third quadrant is formed by this and this line. So, starting from this, when it reaches this line, it travel 180 degree. Then again, if it to get third quadrant, to arrive third quadrant, you have to again rotate in this direction. Some angle, suppose it rotate, then 180 degree plus theta will be there. So it will be in the 180 degree plus theta will be in the third quadrant. Like that, when this revolving ray comes to this position, it travel 90 plus 90 plus 90. 3 into 90 is equal to 270 degrees. So it will travel 270 degrees. But it will be on the line. So when it come back, again goes back to this supposed theta angle, then 270 degree minus theta will be in the third quadrant. Same way, when we consider the fourth quadrant is the form with this and this one. Up to this 270, again plus 90, 360. That means up to this 270, when you add an angle, it will be in the fourth quadrant. And if you go to this position and subtract an angle theta, it will be in the fourth quadrant. So fourth quadrant angle can be written as 270 degree plus theta or 360 degree minus theta. Like this, the revolving ray goes on rotating. এনেকে ঘূৰি থাকিব পাৰে. এতিয়া এইখিনিৰ পৰা যদি আহি আকৌ এইটো পালে, তেনেহলে কি হ'ব? 360 degree rotate কৰিলে. Then if it arrived here, plus some angle will be travel. So 360 degree plus theta will be in the first quadrant again and go on like this. But if the revolving ray, suppose this is a starting line, initial line, if it travel in this direction, acute angle, it will be in this direction, clockwise direction, acute angle theta. So the angle will be minus theta. So these things you have to know, it will be used later on. This is a very important thing. You have got all these things in class 11. Just I want to remind you very briefly. Now you see, you have to know the next thing is even or odd multiple of 90 degree. You see, when you write down these angles, this is 90, this is 180, here suppose it is 360, 270, all these are multiples of 90. 90 can be written as 1 into 90, 180 can be written as 2 into 90, 270 can be written as 3 into 90, 4 into 90, like this. When you rotate, every angle can be written as the multiple of 90 plus or minus theta. So, when an angle is an even multiple of 90 degree, suppose 360 degree, that is 4 into 90 degree. So, 4 is an even number. So, that is an even multiple of 90 degree. In that case, actually these things are used when you want to find out the values of different trigonometric angles. So, in that case, all trigonometric ratios remains as it is. That means sine remains as sine, cos as cos, tan and tan remains as tan. Same is true for others. But if it's an odd multiple of 90 degree, for example, here you see, this is suppose 270 minus theta. 270 degree minus theta is what? 3 into 90 minus theta. Or here 3 into 90 plus theta. That means it can be written sometime as a multiple of, odd multiple of 90 degree plus or minus theta. In that case, you remember trigonometric ratios are changed. Sine changes to cos, then cos changes to sine. I am giving both side arrow. Sine changes to cos, cos to sine, tan to cot and cot to tan, sec changes to cosec and cosec changes to sec. Remember all these things. Actually, why, where, when you have to use these things? You know the values of trigonometric ratios, different standard angles. Okay, I had given these values also. Just see. These standard angles are known to you. Sine 0 degree, 30 degree, 45, 60, 90. sine of this 0 degree is 0, sine 30 degree is half, sine 45 degree is 1 by root 2, sine 60 is root 3 by 2, sine 90 is 1. Same way when you come this direction, that is 1 root 3 by 2, 1 by root 2, half and 0, and all this. This is a very important table you got in class 11. How to find out, I hope remember. But here you try to remember the standard angles values so that you can apply here, there. Because if it is not standard angle, but something multiple of that type of angular plus or minus theta, then you try to convert them into standard form. Okay, and for that purpose, these things are used. These things are used. ASTC rule or these multiples or even or odd multiple of 90 degrees. Okay, so I just give you an example to see how to apply all these things as I told you earlier, just some time before. For example, suppose I want to find out the value of 570 degree. First you see 570 degree, you just divide it by 90 plus or minus theta. Here when I divide it by 90 into 6 will give you 540, remainder is 30. So 570 can be written as 6 into 90 plus 30. 6 into 90 degree plus 30 degree. First you convert it into multiple of 90 plus or minus theta. First step. Second step, you see in which quadrant this angle will lie. Let us count it now. You see it is 6 into 90 plus or minus theta. Plus will go forward, minus will go backward. So 6 into 90, count from this. First quadrant 90, 2 into 90, 3 into 90, 4 into 90, that means we arrived here. 5 into 90, 6 into 90 is this. 1, 2, 3, 4, 5, 6. That means we arrived here. Then we have to use plus 30. So you go forward, plus. That means this ratio will lies in the third quadrant. First, second, third quadrant. First we see in which quadrant they lie. Then we will find out what is the symbol in that quadrant of that particular trigonometric ratio. ASTC rule. This is tan. It means tan is positive. Tan or cot is positive, rest are negative. What is your ratio? Your ratio is sine. So the symbol will be negative. I got the negative sign. After that, you have to see this ratio, this one you apply. Even or odd multiple of 90. See here, it is 6 into 90. That is even multiple of 90 degree. So if it is even multiple of 90 degree, trigonometric ratio remains as it is. So sine will remains as sine and the value is equal to what? Theta. That is equal to what? 30 degree. And this is convert to standard form. And what is the value of sine 30 degree? That is known to you, which is equal to minus half. You remember, try to remember the table of finding out the standard values. Okay. One more example, let me give you. Okay, here you see. I just want to find out cos of 495 degree. Any value we can find out like this. So first, what is the way? We will divide 495 degree by 90. That will give you 5 times 450. Subtracting will have 445 degree. So this 495 can be written as 5 into 90 plus 45 degree. This one. Now you see in which quadrant, that is the first step. First convert it, then see in which quadrant it will lie. 5 into 90, count it. 1, 2, 3, 4, 5. This is in the first quadrant. Okay. So in the first quadrant, that this is in the first quadrant. After that you see here plus 45 degree. That means you have to go to 1, 2, 3, 4, 5. Then you have to go to this quadrant. That means you have arrived here in the third quadrant. So after getting the third quadrant, you see what is the symbol in the third quadrant. Okay. So here it is odd multiple of 90 degree. Odd multiple of 90 degree means what? 5 into 90. So odd multiple. In the case of odd multiple of 90 degree, it becomes the trigonometric ratio changed. Cos changed to what? You see here. I had just already told you now. So cos changed to, okay, here we see odd multiple. odd multiple of 90 degree, then the cos will change to sine, this one. So here we see that cos will change to sine now. This is, I have written here sine, right? And the 45 degree is the value. So we have got the value is equal to what? Minus sine 45 degree. And the value of 45 degree is equal to what? 1 by root 2. So the value of cos of 495 degree is equal to minus 1 by root 2. Hope you understand how to use these things. Okay. Now you see, sometimes the angles are not given in degree. Mostly they are not given in degree, but they are given in radian. So you have a relation between the degree and radian. What is that? 180 degree is equal to pi radian. So you can convert it, you know all these things now. So I am not writing in detail. So you see 90 degree is equal to what? Half of 180, that is pi by 2. 60 can be obtained dividing it by 3. So pi by 3. 45 is pi by 4. 30 is pi by 6, etc. We can get it. Suppose the value is given like this in terms of radian. Then also we can do the same. Suppose you have to get the value of sine of 7 pi divided by 2. So first you see, divide these things or express the numerator as a multiple of the denominator plus or minus pi or the theta. Here it is 7 pi. So 7 pi can be written as 6 pi plus pi. Multiple of 2 plus pi. Then divide it into two parts, 6 pi by 2 and pi by 2. 6 pi by 2 will give you 3 pi plus pi by 2. Now you see, this is pi, but we know the thing in which quadrant we can find out. But better if you change this in terms of pi by 2. So 3 pi can be written as 2 into pi by 2. So it can be written as 6 into pi by 2 plus pi by 2. Here you may have any value. So you see in which quadrant, first aim, you have converted into multiple of 90 plus or minus theta. See in which quadrant it will lie? 6 pi. So 1, 2, 3, 4, 5, 6. 6 pi plus pi. That means it is in the third quadrant. So third quadrant, the symbol is what? Tan is positive. So sine will be negative. So negative symbol let us give. After that, 6 into pi by 2. So it's a multiple, even multiple of 90 degree. Even multiple, sine ratio remains as it is. The acute angle is what? This angle is equal to here pi by 2. Then you know what is the value of sine pi by 2? That is equal to minus 1. Now you see here I give you some formulas. You have got it, all these formulas in class 10 and 11. First one is what? The sine square theta plus cos square theta is equal to 1. That you know, you have got it in class 11. You know how to prove it. Simply here you remember. Okay, I am not giving the proof of these results. 1 plus tan square theta is equal to sec square theta. 1 plus cot square theta is equal to cosec square theta. And if you change the position of sine and cos, that means from here we can derive two more formulas. That is what? Sine square theta can be written as 1 minus cos square theta, or cos square theta can be written as 1 minus sine square theta. Like that, from here, if I write down sec square theta minus 1, that will be equal to what? Tan square theta. Okay. Or if I bring tan to the left side, it becomes sec square theta minus tan square theta, that is equal to 1. Or from here, you can get the value of cot. Cot is equal to what? Cosec square theta minus 1. Like that, the conversion also you have to know. Already I had explained here all these things. Tan theta is equal to sin theta by cos theta, or cot theta is equal to cos theta by sin theta. Sec theta is the reciprocal of cos. Similarly, cosec is the reciprocal of sine. Tan is the reciprocal of cot, and so on. All these formulas you try to remember. All these things will be applied in inverse trigonometric formula. Because in inverse trigonometric chapter, function chapter, you will not get so many formulas. But all the formulas you have got in class 10 and 11 will be used here. Also you see, you know these tables of finding out the values of the standard values, standard angle values of trigonometric ratios. That is what? Those are your 0 degree, 30 degree, 45 degree, 60 degree, 90 degree, and their radian values also you know. What is 0 degree radian value is 0, 30 can be written as pi by 6, 45 pi by 4, 60 pi by 3, 90 pi by 2. All those you try to remember. Okay. Now here you know the values of sine 0 is equal to 0, sine 30 half, sine 45 1 by root 2, sine 60 root 3 by 2, sine 90 1. And if you know the values of sine, just you come from here. you come like this, you will have the values of cos. You see, this is here, this one is there, like that. Okay, similarly tan, cot, sec and cosec, these values you try to remember. Here I give you some results of getting the negative values, how to convert the negative results. You see, I'm giving first sine of minus theta. Okay, now you see sine of minus theta. Theta is acute, as I told you earlier. Until and unless mentioned, theta is considered as an acute angle. So minus theta means what? You know, it is rotate negative direction, that means rotate in the clockwise direction. So minus theta, if you start from this line, minus theta you have to rotate in clockwise direction, that means he will arrive here. And this is the fourth quadrant, 1, 2, 3, 4, fourth quadrant. So fourth quadrant cos is positive, so sine will be negative. So here you have to give negative sign and sine of theta. Now same way, cos of minus theta minus lies in the fourth quadrant, but cos is positive here. So you see here you have to give positive symbol. Same is in the case of tan. What is tan? About tan in the fourth quadrant is negative, right? Because only cos and sec will be positive. So this is negative tan theta. Hope you understand. Okay, now sine of 90 degree minus theta. 90 degree minus theta, first you have to see in which quadrant 90 minus theta is there. 90 minus theta, this is 90 degree minus theta, you have to come back. So it is in the first quadrant. So first quadrant, all positive. So sine, this symbol will be positive. Then it is 1 into, it can be written as 1 into 90. 1 is an odd number. So odd multiple of 90. So sine ratio changes to cos. That's why you know that is sine of 90 degree minus theta is equal to what? Cos theta. Similarly, we have derived all these things. Okay. And say suppose this one I again explain you. Cos of 90 plus theta. Cos of 90 plus theta. 90 plus theta will lie in which quadrant? 90 degree up to this plus theta here. You have to go forward. So it is in the second quadrant. Second quadrant, sine positive. So cos will be negative. So you have to put a negative symbol. This is what? 90 degrees. So 1 into 90. 1 is an odd number. Odd multiple of 90. Cos will change to sine. And angle you have to write down the acute value. Hope you understand. Like that you can do all these things. One more let me explain you. Suppose the last one. Some more, there are more results are there, but I had given some of them. Tan of 180 degree plus theta. Tan of 180 plus theta. 180 plus theta. This can be written as 2 into 90 plus theta. So 2 into 90. 2 into 90 means 1, 2. Plus theta means you have to go to the third quadrant. Third quadrant, tan is positive. So you have to give positive symbol. First see in which quadrant angle lie. Then put the symbol there. Then you see whether it's an even multiple of 90 or odd multiple of 90. This is what? Here it is even multiple of 90 because 2 into 90, right? 2 is an even number. So tan remains as it is. And lastly, you put the acute angle here. So this way you have to convert different types of angle. I had explained here the ASTC rule. ASTC as I mentioned earlier. Okay. There are some more results you have got in class 11. Those for sum of two angles, some sine addition rule, then subtraction rule, then cosine, cot, cos, all the tan, all these things, right? So here you remember the formulas. I have given here two formulas together. Okay. First one is for positive symbol. Sine of a plus b is sine a cos b plus cos a sine b. And if it is negative, the value is what? Sine a cos b minus cos a sine b. In the case of cos, what is the result we get? In case of plus, cos result answer will be minus. So I give here minus sign above. Then cos of a plus b is equal to cos a cos b minus sine a sine b. And what is the value of cos of a minus b? Cos of a minus b is cos a cos b plus sine a sine b. Same, tan of a plus b is equal to what? Tan a plus tan b by 1 minus tan a tan b. You see, first above symbol is for the, here the above symbol is positive. Here the all above symbols are for plus. Below symbol is negative. So all below symbols are for the formula used in minus symbol. Okay. Second one, that is tan of a minus b. So what is tan of a minus b? Tan a minus tan b divided by 1 plus tan a tan b. Same for sum of three angles. And these symbols, when the product of two angles are given, sine and cos, they can be expressed as a sum of two sines. Similarly, these formulas, actually we have derived all from this. These four formulas are derived from 4 and 5, which number 4 and number 5. Okay. Now, here also you have 4 more formulas. That is when the sum of two sines are there. Remember, all these formulas we have to use not only in inverse trigonometric chapter, but in calculus also, and all calculus in differential and integration. Okay. So try to remember it properly. Now sine of C plus D, this is sum of two angles. You can express it as a product. That is what? 2 sine C plus D by 2 cos C minus, like that you remember these formulas. And then number 16 is the multiple of two angles, twice A. You can write down it as 2 sine A cos A, or in terms of 10, 2 tan A by 1 minus tan square A. Okay, both of these you try to remember. Submultiple, here when it is twice A, it become A. If it is theta, that is just a submultiple angle, it become half of theta. This is 2, it become half, that is A. 2A, half of 2A is equal to A. Here theta, so it will become theta by 2. Formula is remaining same. So similarly, cos of twice A, we have got 4 parts of the formula. One is cos square A minus sine square A. When I convert cos to in terms of sine, it become 1 minus 2 sine square A. Or when I change sine in terms of cos, it become 2 cos square A minus 1. And this result in terms of tan is 1 minus tan square A by 1 plus tan square A. So here these are the submultiple angle formulas. Similarly, tan twice A to tan A by 1 minus tan square A, this is submultiple. And these two formula, this is important, very important, remember. 1 plus cos twice A is 2 cos square A, or 1 plus cos theta is half, it will be half. This formula and the next one, this is very important, and it is derived from this 17. Okay. Now, some more formulas are there. Try to remember all the formulas. Regularly you read and write down, try to practice. You can easily remember the results. Okay. So here also the negative 1 minus cos twice A is equal to 2 sine square A, submultiple. Okay. And these are the formulas which are used for tan square and tan square theta by 2. This is for the, if it is the multiple of multiple angle, again twice A, 3 sine A minus 4 sine cube A, cos twice A, 4 cos cube A minus 3 cos A. These are all formulas you have got in class 11. Again, here we have got the general values. General values you have got in class 11. That is what? If sine theta is equal to 0, then theta is equal to n pi, where n belongs to z. This is very important to mention. What is n? These are also used. Similarly, cos 0 is there. Cos 0 is theta, gives you twice n plus 1 into pi by 2. Tan theta is equal to 0, gives you theta is equal to n pi. Then sin theta is equal to sin alpha, gives you theta is equal to n pi plus minus 1 to the power n into alpha. Then cos is there, tan here. And similarly, I had written here some more formulas for inverse trigonometric formula. Okay, but this formula now I am not going to explain you, because I will derive this one by one. Okay, so you see, try to clear the concept of trigonometry properly, right? Read the formulas properly, regularly. And one more thing, here if you want the images of this video, I given all this in the description box. You can see there. Thank you.